In this video, I'm going to show you how to graph a piecewise function. All right, we're going to get into some fairly complex ones, but it will still be a piece of cake. And we'll talk about points of discontinuity as well. So let's sort of color coordinate this as we go. We're going to graph each piece of the function, one piece at a time. So first I'm going to get set up with a nice table of values because that's what I like to use. Wow, that's crooked. Can I do any better than that? All right, if it's crooked this time, guys, it's just going to have to be crooked. You're just going to have to know that I have a crooked mind. All right, to be fair, it's a little bit tricky to do this with a digital pen because I'm writing in one place and then it's showing up somewhere else. Anyway, enough of my excuses. So for the first piece of the graph, we need x values that are less than 1. So I think I'll start changing colors now. So let's do the first piece of the piecewise function in red. And I'm focusing in on the domain over here. This is the part that tells me which x values to use. It says x is less than -1. So you would think I would start with -2, but I'm not. I'm going to start with -1 when I do this. But I'm just going to remember that because x is less than -1, not equal to, this is definitely going to be an open circle when I graph this. Okay, I'm just putting this to remind me that's going to be an open circle. Anyway, so I need x values that are less than -1. So I'll start with -1, and then I'll go -2. Okay, I'll go -2, -3. That's probably going to be enough. Okay. Yeah, that should be enough. Okay, for the next piece of the graph, we'll do that in purple. And the domain, again, tells me which x values to use. I need x values between -1 and 2. So I'm going to use x values between -1 and 2. All right, so I'm going to go -1. I'm going to go -1, 0, 1, and 2. All right? Okay, now be careful because, okay, notice how the 2 does not have the or equal to sign. So the 2 cannot actually be included. So the way I show that is by making that an open circle as well. So that should be an open circle. All right, now for my third piece of the piecewise function, we'll do that one in green. And for the domain, I want values that are x values greater than or equal to 2. All right, so I'm going to, even though it says greater than or equal to 2, I'm definitely going to start with 2, well, which I would anyway because it does say equal to 2. But even if it said greater than, I would still start with 2. But then I'll do 3 and 4. All right, and hopefully this will be enough. I can always add more if I need to. All right, so I'm just going to put these values into the function and kind of see what I get. All right, let's start with the red part. So this is x squared, the opposite of x squared, plus 4. Okay, so I'm going to show this one, and then I'll do the other two in my head. But x squared, if x is -1, understand that is -1 squared, right? But then it says this negative sign in front of it. So I have a negative sign out there. And then I have the plus 4, all right, right there. you have to do the -1 squared first. So this part is going to become a positive 1 after I square it. But then I still have the negative sign out front. So this is really like having -1 plus 4. So I'm going to have 3 for the answer. So you should be able to do all that in your head. I just had to show it to you one time so you understand that first we square the number, then we apply the negative sign, and then we add. So that's kind of the order of operations, if you will. Okay, so first we square the -2 and we get positive 4. But then the negative sign makes it a -4. The -4 plus 4 is 0. So we're going to get 0 now. First we square the -3. That's positive 9. But then this makes it a -9. And then plus 4 gives us a -5. Okay, now let's do the purple part. All right, absolute value. The absolute value of -1 is positive 1. But then positive 1 times -2 is -2. The absolute value of 0 is 0. 0 times anything is 0. The absolute value of 1 is 1 times -2 is -2. The absolute value of 2 is 2 times -2 gives us -4. Green part. Okay, if I put a 2 in here, 2 minus 2 is 0. 0 cubed is still 0. If I put a 3 in here, 3 minus 2 is 1. 1 cubed is 1. And if I put a 4 in here, 4 minus 2 is 2. 2 to the third power is 8. So we get 4, 8. All right, so it's time to start graphing these points. When I look at the first piece, I see that the parent function is x squared. So in my mind, I'm thinking, okay, this is going to be a parabola. The negative sign means that it's going to be a downward facing parabola. So this is in my mind. As I graph this, it will help me understand what's happening. Okay, so -1, 3. All right, -1, 3 would be right here. This is reminding me to make this an open circle. So let me just erase that little dot. Okay, -1, 3, open circle. -2, 0. And -3, -5 would be here. All right. Okay, so this is, if I had the full parabola, okay, this is an upside down parabola that has been moved up 4. So the vertex would have been here. So if I had the entire parabola, it would have looked like this. All right, that's what the whole parabola would have looked like. But we're just going to have this part over here. So this part is going to look almost like a straight line. There's not much curve to it between these 3 points. But just understand that it is the left side of a larger parabola. That was almost it right there. So we're just going to draw that part. And yeah, it's going to look pretty straight. But as you saw, that's actually a part of a whole parabola. All right, next, let's do the purple part. As I look at this, I understand that the parent function is the absolute value of x, which is a v shape. The negative makes it upside down. So in my mind, I know that I should be looking for an upside down v shape. So just keep that in mind as we graph. So -1 negative 2. Okay, negative 1, negative 2 would be right here. 0, 0. 1 comma negative 2 would be right here. And 2 comma negative 4. Now, I put this here to remind me that this is an open circle. Okay, 2 comma negative 4, open circle. So you can see the upside down V happening. That's what we were expecting. Guess I just have to draw it again. All right, so that's the middle section. And here comes the final piece. 2 comma 0. Oh yeah, the parent function here is x cubed. And we know that a cubic function looks like this. It does what's called a point of inflection, like right here. Now, because this has the minus 2, it's going to be one of these that is shifted over to the right by 2. So this point, 2 comma 0, should be the point of inflection, where it goes from being downward, concave down, or curving downward, and then it goes to curving upward. So keep that in mind. So I'm actually expecting, because the whole graph would do something like this, concave down, concave up, all right? That's what I'm expecting. So the right-hand side, okay, after the point of inflection, I'm expecting this to curve up. So just keep that in mind. So 3 comma 1 would be right here. And then 4 comma 8, all right, that's going to be a tiny bit off the graph, but that's okay. And so, yeah, we see that it's curving up just as we anticipated. I'm kind of missing a little bit here. Okay, so your graph should look very much like this. Now, let's talk about discontinuity. Real quick, please remember that there are 3 types of discontinuity. We have jump discontinuity, where the graph takes a gap like that. All right, that would be a jump discontinuity. There's a removable discontinuity. All right, that's where the graph just has like a hole in it. All right, that's a removable discontinuity. And then you have an infinite discontinuity. That's where you have an asymptote, and that's why you have a break in the graph. So maybe the graph is going like this because there's an asymptote there. All right, that would be an infinite discontinuity. Now, we see we have these gaps in the graph. We have one here at -1, and then we have another gap here at an x value of 2. So there's a discontinuity at -1, and there's a discontinuity at 2. Both of these are jump discontinuities because we see the gap in between. So we're just going to say jump at x equals -1, jump at x equals 2. All right, let's do one more of these on this video. So here we have one more piecewise function, and we are going to graph this thing. Okay. I might need this space. Okay, so here's the first piece of our piecewise function. And let's start by focusing on the domain. The x values are less than or equal to 0. So that means we're going to have values like, okay, so we need less than or equal to 0. So we're definitely going to have 0 included. So I'm going to put 0. And now if I go less than 0, that's going to be like -1, -2, and that'll probably be enough. All right, I think I'll just stop with those 3 values. Okay, now let's switch over to the next piece of the piecewise function. All right, and the domain tells us that we want x values between 0 and 3. So I'm going to give x values between 0 and 3. So that means 0, 1, 2, 3. One thing to be careful about, see how the 0 has a less than, not less than or equal to. That means 0 is not actually going to be included on the function. So we need to show that by making this an open circle. So I'm just going to put this little open circle here off to the side just to remind me that this point is going to be an open circle. All right, and finally we will do the third piece in green. The domain tells me that the x values need to be greater than 3. Even though it says greater than 3, I'm still going to start with 3. But again, because it can't equal 3, this is going to have to be an open circle. All right, but I still need it as a point on my graph to show the values going right up until 3. All the decimals and fractions that are really close to 3 will I'm going to need this as an endpoint. Anyway, greater than 3. So 3, 4, 5. Okay, now these are going to be decimals. Can I be any smarter than this? 3 is good. 4 is good. All right, I think I'm gonna try to be clever. When I said 3 was good, in my mind I'm plugging 3 in to the square root, right? 3 minus 3 is 0. Square root of 0, I'm good. Okay, that's gonna be 0. You know, as long as I'm thinking this out, I might as well write this down. So if I plug in 3, I get 0, and then 0 plus 2, that's going to be 2. All right, so I'm not dealing with decimals. If I plug in 4, 4 minus 3 is 1. Square root of 1 is still 1. 1 plus 2 is 3. Now, I'd really like one more value, but I really don't want to have a decimal. If I put 5 in here, then I'm going to have the square root of 5 minus 3, okay, and then plus 2. But 5 minus 3 is going to be 2. And I don't know how to take the square root of 2. Like this, that's going to be a crazy decimal. So instead, okay, what can we easily take the square root of? An easy square root would be 4. All right, if somehow I could make this turn out to be 4. Well, so what needs to go right here in order for me to get 4 so I can take the square root of it? Something minus 3. So that's going to be 7. So if I'm clever. Now, it would have been okay, I guess, if you just did 5 and you got a decimal, like whatever, it's fine. But most of you can understand what I'm doing, and you can figure out that if you are careful, you can come up with better, easier to graph values. So if I make the x value 7, then that's going to be 7 minus 3, which is 4. So then I've got the square root of 4 plus 2. So that's 2 plus 2, which is 4. And for me, that is a lot more satisfying than having a weird decimal right there. Okay, now let's go back and do the other parts. If I put in 0 right here, okay, so that's just going to be 1/3 plus 1. All right, so this is going to be decimals and stuff anyway, so there's really no way to avoid it. All right, so if I put in 0 right there, and I'm going to just do my calculations off to the side, then I'm going to end up with 1/3 plus 1. In other words, that's going to be 1 1/3. So that's going to be approximately 1.3, right? It's 1.3 repeating. So 0 and approximately 1.3. That'll be close enough. Okay, if I substitute in -1 right here, so then I've got 1 over -1 plus 3 plus 1. So that'll be 1 over 2 plus 1. Okay, in other words, this is going to be 1 1/2, also known as 1.5. So at -1, we are at 1.5. Okay, what about at -2? If I do -2, then that's going to give me 1 over -2 plus 3. All right, so that's going to be 1 over 1 plus 1. So that's just going to be 1 plus 1, so that's going to be 2. Moving on to the purple portion of the piecewise function, I've got this 3x minus 5. So 3 times 0 is 0, minus 5 is -5. 3 times 1 is 3. Minus 5 is -2. And 3 times 2 is 6. Minus 5 is 1. And 3 times 3 is 9. Minus 5 is 4. All right, it's time to start doing the graph. Let's go back and start with the rational function here shown in red. Now, as I'm looking at this, it's occurring to me that we are probably going to need more points than this. And I'm going to tell you why right now. A rational function. So looking at this first piece, the parent function is 1 over x. Okay, this is the parent function. And we have memorized, really, that the parent function has the following look to it. There's going to be a branch here, and there's going to be a branch here. All right, we've memorized the basic look of all the parent functions, and this is one of them. Notice there's a vertical asymptote and a horizontal asymptote. The two transformations that are happening, the plus 1 is going to shift this up 1. So that means that there will be a new asymptote, which normally would be the x-axis. That asymptote will now be at 1. The plus 3, this is a left-right motion, and it's the opposite of what it looks like. So this plus 3 is actually going to be left 3. So that means the vertical asymptote, which was the y-axis, will now be at -3. Okay, now, so here's why I said we're probably going to need additional values. Based on what we've memorized, we know we're going to have a branch up here, and there's going to be a branch here. So I'm not going to be super careful right now. I'm just showing you the rough idea. So we're going to have a branch here, and we're going to have a branch here. Right now, our x values are 0, -1, and -2. Those values are only going to be on this right-hand branch. We have no values over here on the other side. So we're going to need at least one value over here. Notice that we really need to skip over -3 because that's an asymptote. All right, because remember, the domain is x is less than or equal to 0. So I started at 0 and I was picking numbers that were less than 0. And if you picked -3, what would happen? So you would put -3 here. -3 plus 3 is 0. That's 1 divided by 0. That's undefined. So that would be undefined. And that would just remind you that there's an asymptote right here. So that would leave you still needing another value. So let's do -4, for example. That's going to bug me. If we're doing it in blue, let's just stick with blue, eh? Okay, so x's and y's. So if we do -4, then what's going to happen? All right, so I've got 1 over -4 plus 3 plus 1. So that's going to give me 1 over -1, right, plus 1. So that's going to give me -1 plus 1, which is going to give me 0. So -4 comma 0 is also a point. So you really are going to need at least one point on both sides of the asymptote. So if you have a rational function like this, you better keep on going until you have points on either side of that asymptote. Okay, so now let's use the points to do a better sketch. So -4 comma 0 is right here. So that shows me that when I draw this branch, it's going to have to go through that point. All right, something like this, and approaching the asymptotes. Now 0 and 1.3, all right, so that's just barely above the number 1. And -1 is at 1.5, so that should be right here in the middle. And then -2 is at 2. So -2 comma 2. So you can see the branch that's happening right here. That's curving down and passing through these points. Is that going to make the whole thing go away? Boo! All right, this is tough. You get the idea, man. Oh no, I didn't need to graph all that anyway. Gosh darn it. Okay. I forgot that we're stopping at we have to stay less than or equal to 0. So that last little part that I was trying to draw, we're not supposed to be drawing that anyway. All right, we're stopping here at 0 comma 1.3. That's the end. All right, because then we pick up with the purple part. 0 comma -5. Remember, this is an open circle, so 0 comma -5, this part of the graph picks up right here. This will be much simpler because this is just a straight line. So 1 comma -2, 2, comma 1. Okay, all right. Obviously this asymptote has nothing to do with this graph. All right, that was just for the previous part. In fact, maybe I'll erase a little bit of it to remind us that this has nothing to do with anything over here. And 3, comma 4. All right, so that is this piece of the graph. All right, and now we'll do the green part. So remember, this is a square root function. So the parent function is the square root of x, and we memorized, hopefully a long time ago, that the parent function, square root of x, looks like this. All right, it's sort of half of a sideways parabola. Now, this particular function has been shifted right 3 and up 2. So right 3 and up 2 would be right here at the point 3, comma 2. All right, which is actually the first point on our little list here. But this is this point right here, just shifted right 3 and up 2 like this. This reminded us to make it an open circle though. And then we have 4, comma 3 is going to be right here. And then 7, comma 4 is just a tiny bit off the graph, but it's still good. Be right about here. And we see the shape that it's trying to make. So we're just going to make that curve. All right, and there you go. We have now graphed this magnificent piecewise function. Oh yeah, we still have to talk about points of discontinuity. I almost forgot about that. Okay, remember, discontinuity. That's going to be breaks. Any break in the graph is going to be a point of discontinuity. We have a break right here at -3. This is an asymptote. That makes this an infinite discontinuity. All right, so I'm going to have to squeeze this in here. I think I'm going to go with a smaller font. Okay, so because we have 1, 2, we have 3 discontinuities. So we have an infinite one at x equals -3. All right, this vertical asymptote. Infinite at x equals -3. And then we have another break right here at 0. All right, right at the y-axis. This is a jump. So we're going to say that we have a jump discontinuity at x equals 0. And then we have another jump right here at 3. So we also have a jump at x equals 3. All right, and that is it. So that is how you graph a piecewise function, and that's what discontinuities are.